Hello everyone. We were discussing about the different measures of the process and we'll continue our discussions. We looked at the concepts related to flow unit, flow time, flow rate, and inventory. Now, for us to understand how we arrive at the flow rate of any particular processes, the important element that we need to discuss is this concept of processing time. Now, processing time is something that you already know. This is not a very new concept. This is something that you keep using in general. Processing time is nothing but the time corresponding to any particular activity, the time that the worker, the machine, the file, the activity, how much time does it take, right? Now, if you have gone through the custom cookie case, you would remember that the oven was taking about 10 minutes to complete that particular activity, which is what we call as baking. And that particular time that the oven was taking is what we would call as the processing time of that particular activity or the resource, the oven, the machine, the worker, whatever you would want to call that. Now, the processing time is only corresponding to the time corresponding to that particular activity. So we remember our discussions where we have referred to activities using rectangles. So the processing time is corresponding to that. Now, corresponding to the processes, we also have something called as a capacity. Now, how do we measure capacity? Now, again, this is something that you already are familiar with. This is very simple to answer. So if I say that any particular process takes about 10 minutes to complete, and I would ask you how many total number of units can we complete in 1 hour, you would intuitively answer that the total number of units that you would complete is going to be 6. Now, the way we arrived at the particular thing was based upon our calculation, that is 60 divided by 10 gave us the answer as 6, right? Now, if you think about it, that is how we arrived at this particular thing. We said that the total number of units that can be completed in 1 hour is corresponding to the processing time that we have. Now, if I rephrase this particular question as how many units will be completed within 1 minute, then the answer is just going to be 1 by 10 units per minute. So this is the way we would look at. By that same logic, if we say that the processing time of any particular activity or resource or worker or machine is P, the capacity corresponding to that particular activity, resource, worker, or machine is just going to be 1 by P, right? This is how you would look at it. Now, corresponding to this, if you think about in general, when we talk about processes, there is not only one particular worker or machine who is working on that. There could be more than one person who is working on that. And let's take an example of painting the wall of any particular house or the different walls or of any particular house. Now, if we have one particular person who is painting the walls, then the processing time of that particular person corresponding to let's say 1 square footage of on that particular wall is, let's say, given by processing time B. Now, if that single person is going to complete that entire house, it is definitely going to take more time. As opposed to that, if let's say more than one person is working on that particular activity, which is more common than otherwise, then you would have the total activity completed in less amount of time. Now, the time it takes to complete painting is definitely dependent on the square footage, right? Now, here, let's assume that there are n workers, each having the same capability or same processing time, and each of them are working simultaneously. Then the time it would take for them to complete this entire activity, which is nothing but their capacity, can be given as not the time though, but the capacity, the speed at which they can do is going to be nothing but n multiplied by 1 by p, which is going to be n by p. So the capacity, when there are n number of workers, machines working simultaneously at the same speed which is corresponding to the processing time of P, the capacity is just going to be N by P, not NP, not 1 by Pn, it is N divided by P, right? So that's how you look at it. Now, another very important process metric is what we call as the bottleneck. Now, bottleneck is a word which we very commonly use in our general parlance, where we say that bottleneck is that particular thing which is restricting our flow, something that is stopping things from happening and things like that, right? Now, it is very intuitive to understand that the word bottleneck comes from the neck of the bottle, which is restricting the entire flow of water coming out. Now, imagine there is no bottleneck and we are directly gulping water from it. You would probably throw all the water on yourself, and which is what the neck of the bottle is actually helping you restrict the flow. Now, bottleneck is also used in things like when you are going in a traffic and there is a particular junction where there is a lot of blockage. That is also something that we are referring to as a bottleneck. While there are many definitions to bottleneck, one thing that we generally use is that particular activity or resource or worker or machine which is going to take the highest amount of time or the lowest or has the lowest capacity. That is what we refer to as our bottleneck. Now, there are other ways to define bottleneck as well, but we will look at that later. So in general, also, if you think about it in any particular processes, you will see that that particular process step, which has the highest amount of processing time, is something that we call as the bottleneck, right? Now, the way to see this particular thing is provided over here, a small setup where we are thinking of this like a traffic. There is a road which has different widths. As you can see that in this particular place, there is a blockage which is happening, which is only restricting one, let's say one car to move away from this, while there are multiple cars which are coming in, right? So this is what this particular bottleneck does, right? Now, bottleneck is very, very important in any particular process. You can think of that as a protagonist, whether it is the hero, heroine, villain, whatever you want to call it, because without bottlenecks, you cannot assess what the overall capacity of a process is going to be, right? That takes us to the next metric, which is what we call as the process capacity. Now, process capacity is nothing but the maximum capacity the entire process can handle. And this particular definition says that the process capacity is nothing but the capacity of the bottleneck. Now, why is the process capacity the capacity of the bottleneck? Now, what does it mean? So if you look at it, let's assume that we have a particular process which has 3 different activities which are happening simultaneously. And let's say the processing time of one particular activity is 5 minutes. The other one is 10 minutes. The other one is about 6 minutes. Now, correspondingly to each of these activities, we can calculate the capacities as well. So the capacity corresponding to this would be, let's say, for example, if we are calculating that for R, this will be 60 divided by 5, which is going to be 12. This will be 60 divided by 10, which is 6. And this is going to be 60 divided by 6, which is 10. So these are the processes. These are the capacities of each of the different activities. Now, from our definition of the bottleneck is that particular process or activity or machine which has the highest processing time and the lowest capacity. Now, as you can clearly see over here, activity B is our bottleneck because this has the highest amount of processing time and the lowest capacity, right? Now, the definition that is given over here indicates that the process capacity, the capacity at which the entire process can churn out the output, is going to be only dependent on B, which is the bottleneck. Now, that is a very, very interesting thing, purely because it says that it doesn't matter at which rate are you running other things, other activities. Even though your activity A might be running in a time gap of 2 minutes or 5 minutes or 6 minutes, or C running at 1 minute or 3 minutes, the entire process output is only going to be defined by B. That is what this particular thing is telling us. Now, so because B has a capacity of 6, now we can say that the capacity of this particular process, the entire process that we have given over here, is going to be just 6 units per hour, right? This is what our process capacity is going to be, right? This is what the process capacity is going to be. The next metric explains as what the flow rate is going to be and how do we calculate that. Now, please understand that, remember how we defined flow rate. Flow rate was defined as the total number of flow units coming out of the system per unit time, right? Now, we also referred this process capacity as the output that is coming out of this. But please understand that process capacity is not exactly the same as flow rate. Why do I say so? So let's take this example. Let's assume that here, let's assume that this is the 3 different activities corresponding to any particular patient's doctor visit, all the patients coming in and coming out. So let's say every hour there are 10 customers who are coming in at the customers are coming in at 10 customers per hour. Now, as you know from this particular definition of process capacity, only 6 customers can come out. So even though 10 customers come in, even though 20 customers come in, the rate at which customers are going to be processed is only 6 customers per hour. Right? That is very intuitive from the definition that we have taken previously. Because the process capacity is nothing but the capacity of the bottle. That is what we have defined. But what if 4 customers come in per hour? Remember, our process capacity is 6 customers per hour or 6 units per hour. We only have 4 customers per hour who are coming in. So 6 customers per hour cannot go out. It is not physically possible. You can only have 4 customers per hour going out. That means that even though our process capacity is 6 customers per hour, we are only serving 4 customers per hour. And what is it dependent on? It is dependent upon this particular value, which is nothing but our demand. So if you look at this definition, that is flow rate is minimum of demand comma process capacity, you will get the answer correctly. Now let's take both the situations. The first situation had the demand being 10 and the process capacity being 6. So the minimum of 10 and 6 is 6, which is what our flow rate is. In the second situation, flow rate was minimum of 4, 6, now 4 being our demand, so the flow rate is just going to be 4. So depending upon the demand as well as the process capacity, your overall flow rate is going to be adjusted. So just because you found out that there is a bottleneck in a system does not necessarily mean that you can get the answer to the output, that is the flow rate that is coming out. You also need to understand what is the demand that is coming in. That is what this flow rate is telling us, right? The next important metric that we talk about is this concept called as cycle time. Now, the cycle time can also be calculated as 1 by processing capacity, right, or process capacity, or it can also be considered as the time gap between 2 successive outputs which are coming in, right? Now, 1 by process capacity, if you look at it, let's try to understand it. 1 by process capacity is nothing but 1 by capacity of the bottleneck and we know that capacity is nothing but the processing time 1 divided by the processing time of the bottleneck. So if we look at it this way, if we look at it this way, then it is 1 divided by 1 divided by processing time of bottleneck. So cycle time is nothing but the processing time of the bottleneck. So go back and think about what is the cycle time in the custom cookie case. The bottleneck is that particular activity which is taking the maximum amount of time. So try to identify what that particular thing is. Correspondingly, then what would the cycle time be? the processing time of the bottleneck be. Right? So think about that in that particular case. Now, this time gap between two successive outputs is applicable when there is enough demand, when the demand in this particular case is usually greater than the process capacity. If it is not so, the time gap between two successive outputs is slightly going to be different than the processing time of the bottleneck. But that is for later. You can look at that later. But traditionally, whenever the demand is greater than the process capacity, you'll always find that this cycle time is the time gap between two successive outputs. The last metric which is of use to us is this concept called as utilization. Utilization is flow rate divided by capacity. Now, what do we know about flow rate? Flow rate is nothing but minimum of demand comma process capacity, and hence utilization is just going to be minimum of demand comma process capacity divided by process capacity. Now imagine if there is enough demand which is out there, then demand is going to be greater than process capacity. So if demand is greater than process capacity, then we know that, so this, just to quantify this is a utilization of the entire process. Now you can calculate the utilization of individual activities as well. That is separately you can do that. So utilization is always about how much you are doing in the time that you have, right? So that is how utilization can be calculated. So here we are seeing that minimum of demand comma process capacity divided by process capacity. So if you know that if demand is greater than process capacity, then flow rate, which is minimum of demand comma process capacity, is going to be nothing but process capacity. So that implies utilization, which is usually represented by the letter rho is a Greek letter which looks similar to P. So rho just has a slightly curved line that goes in. So rho is nothing but PC divided by PC, which means that I have 100% utilization. Now, there are some cases where utilization can be greater than 100% as well, but that's a slightly advanced topic. If time permits, we will look at that particular thing as well. But in cases where demand is, so you can put this as equal to as well, if demand is less than process capacity, then our fill rate is going to be nothing but minimum of demand comma process capacity, which is just demand. So in that case, utilization that we are getting is going to be D divided by PC, which is usually less than 100%. Right? This is what we generally talk about as utilization. I hope you've got clarity on the majority of the process measures which we have used and which we are going to use. So please make sure that you go through this video more than one time in case you have any doubts. You can always reach out to me on my email ID in case you are not able to understand any of these. But please go through this in detail because this is very, very important for us to understand process analysis. Thank you. Thank you very much.